I saw this integral on YouTube. It's a very interesting integral. I have a different method to do it. I think my method is very good, so I will just share with you here. Now I start with substitution. Let x be 1 over t. So my integral becomes arctangent t square, and then times 1 over t square negative, and a dt. And the boundary been changed. Okay. Then I use this negative to switch. Okay. Let me change it t for x. So these just dummy variables. Arctangent x square over x square dx. Yeah. Now from here I can use what the Feynman's technique. So I create a function f of a is equal to integral arctangent ax square and x square dx. Then I take, well, I have a condition that f of 0 when a equal to 0 is 0, right? My target integral, my integral is equal to f of 1, right? Equal to f of 1. Yeah, when a equal to 1 is my target integral. Okay, then the derivative of f with respect to a is the partial derivative for the integrand with respect to a. So that will be 2 uh, 2 arctangent ax or x squared. Then the derivative of arctangent ax, which is equal to 1 plus x squared, right? Yeah. Times, because x is constant, a is variable, times x again, and dx. Yeah, it's good. Now then, simplified is 2 simplified a little bit. This is x cancel out, arctangent ax x 1 plus a squared x squared and dx. Wow. Yeah. Then I'm using substitution again. Let u be ax. I have used t already, so let me use du, and dx will be du over a, right? Yeah. So my integral becomes twice arctangent u, and x will be u over a, and 1 plus u squared. That is this, and times du over a. That's for dx. So I'll simplify a little bit. The boundary is not changed. Twice a cancel out. let me write u for x. Okay, these are just dummy variables. Is equal to arctangent x and x1 plus x squared dx. Good. So this is my f prime of a. Okay. Well, it's interesting that this one has no a, which means f of prime of a is independent of a, is free from a, so nothing to do with a, which means f prime of a is a constant because nothing to do with its variable. So this means that f of a is equal to c x plus another c, right? This is c2, this is c1. Okay, then since f of 0 is 0, f of 0 is 0, which means c2 is 0, right? Therefore, f of a is c1 times x. We are looking for I, right? I is equal to 1. F of 1. So equal to f of 1 equal to c1. c1 is my objective integral object. Yeah, that is c1, right? This is c1. f of a, f prime of a is this. No, f of 1 is c1. c1 is this. Yeah, that is this. F prime of a equals c1. So we are looking for this integral. So which means that integral is this, twice arctangent x1 plus x squared dx. That is my objective, yeah, integral, right? That's what we're looking for. But it's still not easy. This is still not easy because they have arctangent. Your denominator is a third degree polynomial. So, so what to do? Well, I'm using Feynman trick again. So I'll let g of a, now this time use g, is equal to integral arctangent ax over x1 plus x squared dx. Wow. Which means that g over 0 is 0, right? My target integral is a twice of g, right? Is a twice of a g1, yeah. Now this is big. This becomes my focusing. What become my focus after focusing on a g of 1. Well, okay. G of a is this, and the derivative of a g, the derivative of a g with respect to a, which is g prime of a, is equal to integral, this one derivative with respect to a. Then we have x1 plus x squared This derivative with respect to a is a 1 plus a square x square. Since a is a variable, x is a constant, so times x again, right? Yeah, and then dx. Wow. Okay, so x cancel with this x, it becomes integral dx 1 plus ax 1 plus x square 1 plus ax a square x square. Wow. And then of course we are using partial fractions, right? So partial fraction, that is 1 plus x square 1 plus x square is equal to 1 plus x square. There's a no linear factors of for x, so it simply becomes this 1 plus a square x. Yeah. Now then a times this one, a times plus b times 1 plus x squared equal to 1, right? Then you can easily find that, well, let omit something. This is b is equal to negative a squared plus. Well, this let me omit some steps for simple arithmetic. So I found a and b. So my g prime of a, my g prime of a is equal to, becomes two integral, right? Becomes integral a is this over 1 plus x squared dx, and minus integral a square 1 minus a square, that's b, 1 over a square b a square x square dx. Well, for x, this is constant, taking out. This is arctangent, x, right? From 0 to infinity. That one, a square 1 minus a square. Well, this is equal to 1 plus ax square, and the dax 1 over a, right? Just balance. For that one, so this one equal to this one is equal to 1 over a square. This is equal to half pi minus a cancel out, cancel 1a. This is arctangent ax from 0 to infinity. So this one equal to pi to 1 plus a square minus, this is a1 minus a square. This is half pi as well. So it becomes a pi over 2 1 plus a, right? Yeah, half pi, half pi. Is that correct? Mm, yeah, plus C. Sorry, forget a C. Now, because because G of 0 is 0. No, G prime of A is this. G prime of A is this, right? Yes, there's no C here. Okay, I'm sorry. So G of A is integral of pi over 2 1 plus A. Yeah, dA. That is what I should do. Yeah. So this one equal to pi over 2 and log 1 plus A, right? Plus C, yeah. That's better. Okay. So G over 0 is too many papers. Where is my G over 0? Here. Where's my G? Excuse me. Where's my G? Where's my papers? Here. I found G over 0 is 0. G0 is 0. Therefore, G over 0 is 0. So which means that 0 is equal to half pi times log 1 plus C. Yeah. G of 0 is 0. Therefore, G of 0 is when A equal to 0, which means log 1. Log 1 is 0, right? Therefore, C is equal to 0. Yeah, therefore, G over A is equal to pi over 2 log 1 plus A. Okay. Then what is my target integral? My target integral is a 2 over G1. My target integral is a 2G over 1, which is equal to 2 times pi over 2 log 1 plus 1. Yeah. So it end up with pi log 2. That is my very result for my integral I. Wow.